Hello, everyone, and welcome to SymCloud Platform in Action Conference 2023. My name is Yogesh Raheja. I am a senior solution architect at Thinknyx Technologies. I am Kubernetes certified associate and have been working as DevOps, automation, container, and cloud coach. I have been helping many organizations to start their journey in DevOps, infrastructure as code, containerization, cloud computing, and assisting them in automating their regular repetitive tasks using the best possible practices. I have written few books like Effective DevOps with AWS, Automation with Ansible, and Automation with Puppet, which has been published globally by Pact and John and Wiley Publication. So let's get started. The agenda for today is to understand SymCloud platform offerings, setting up SymCloud platform from scratch, understanding SymCloud platform terminologies, dashboard walkthrough, followed by all live hands-on labs and examples. So as we know, containers are the isolated, lightweight applications which contains application code, their dependencies, base operating system, and anything else which you need to run your applications, which justify build anywhere and run anywhere philosophy. But hold on, is it sufficient to run containers in production? What about self-healing, scalability, load balancing at container level, zero downtime application upgrade, and much more? This is where the role of container orchestration will come into a picture. At a scale, this journey was actually started with one of the Docker's orchestrator called Docker Swarm. But since Kubernetes came in the market, the whole game is changed. And at present point in time, Kubernetes is the de facto orchestrator when it comes to managing your container-based applications. There are various offerings available to get started with your Kubernetes-based platform. So you have native Kubernetes, you have enterprise Kubernetes, and you have managed Kubernetes. So native Kubernetes is absolutely free and is completely open source, but it comes with its own challenges. Many organizations have taken native Kubernetes and built their own Kubernetes platform by reducing complexity and by adding multiple features on top of it. So we have OpenShift, Tanzu, SymCloud Platform, MKE, Rancher, and many more, which can help you to set up your own private container-based Kubernetes platform in your own premises. Likewise, if you just wanted to focus on developing and deploying your container-based applications, you can rely upon cloud-based Kubernetes offerings, popularly known as managed Kubernetes. So we have GKE, AKS, EKS, which are provided by Google Cloud, Amazon, and from Azure from Microsoft. So without further delay, let's deep dive into the world of SymCloud platform. So now, when we talk about setting up SymCloud platform, now the flexibility is you can install, you can set up, you can deploy SymCloud platform on any of the environments. It can be on premises bare metal. It can be any virtualized environment which can give you VMs. You can host it on any of the popular cloud platforms like Google, Amazon, IBM Cloud, or Azure. Now, when we talk about installation methods, there are two types of methods in which SymCloud platform can be installed. One is manual and one is automatic. It completely depends upon a customer if they wanted to go with a manual approach to understand ground up, or they wanted to go with the Go Robin utility, which is provided by SymCloud to get started with everything automated. Now, before I go further, let me tell you, I am going to use a term called Robin many a times. Now, when we talk about SymCloud, it was actually a company called Robin Inc. And Robin was having three different products in them. One is their MDCAP, one is their CNP platform, and one is their CNS. Now, Robin has been acquired by Rakuten, and then Rakuten have created a separate vertical, which is called SymCloud platform. Hence, if you are saying SymCloud platform, which is actually equivalent to the previous term called Robin CNP platform. So SymCloud platform, which is the actual name today, was popularly known as Robin CNP platform in the past, right? So we can go with the manual approach or automatic approach, and both of these approaches will provide us two different ways to set up your SymCloud platform. One is HA and one is non-HA. So when we talk about POC, when we talk about doing some testing, creating dev environments or test environments, again, Being cost effective, we can always go with a non-HA approach. But when it comes to production, when it comes to DR, we cannot take a chance so that our applications or platform or infrastructure give us any downtime. And hence, in such cases, SimCloud, Rakuten always recommend us to go with the HA so that there should not be any downtime as far as the infrastructure is concerned. In this particular session, what I'm going to do is I'm going to use a manual approach and I'm going to create non-HA based SimCloud platform from the scratch. So I'm going to do everything in front of you. So wherever we stuck, we will find a solution ourselves. Else, it will going to be the entire installation in front of you. Now, when we talk about creating or installing SimCloud platform, now we need to understand many things. Because when you talk about creating a resilient and a perfect platform, it should always be ground up. So we have to be very careful when it comes to the prerequisites. Now, what we need to have. So as I'm going with non-HA, so I'm just going to demonstrate how to set up a two-node SimCloud platform cluster. So we are going to have two servers. One is going to be our master node and one will going to be our worker nodes. But can we use any master node or can we use anything which can work as a worker node? The answer is no. There are certain strict prerequisites which are applicable to any of the enterprise Kubernetes platforms, right? So we are having multiple prerequisites which we have to follow, right? So we should have the memory. Now I'm writing here minimum 4 GB, but ideally it should be minimum 16 GB. So I have written here 4 GB because it is mentioned in the documentation of SimCloud platform, but the actual memory which is required, especially for the master node, will be 16 GB. So number of cores, you should have minimum 8 CPUs. There are specific storage requirements which you should always follow. You can set up master node or worker nodes on CentOS, RHEL, or Rocky Linux. Firewall needs to be disabled. Host resolution needs to be work. Obviously, if we are talking about clusters, servers should be able to talk to each other. SE Linux should be disabled. Good part is once your SimCloud platform is up, there is a way to enable SE Linux as well. Swap should be off, again taken from the native Kubernetes prerequisites. Time server should be there so that all of the nodes in the cluster should be in sync. You should have specific ports which should be open. Now we know there are certain ports which Kubernetes always recommend us to open so that it can work. Additionally, there are a couple of more ports which you have to allow so that SimCloud platform can seamlessly work and get installed. Especially when you want to access UI or when you want your RCM, which is called Robin Control Manager, services should talk to each other. So you have to allow certain ports which are all documented, very well documented, rather, I should say. So there are specific file systems and partitions which we need to create. IP forwarding should be enabled so that the hypothetical virtual interfaces can talk to each other. And obviously, we need to download the binaries of SimCloud platform. Once these prerequisites are done, we are in a position to get started by doing the deployment of our SimCloud platform. So step number two will going to be the pre-checks. Now these pre-checks needs to be run on all servers. If you are creating a 2 node, 3 node, 4 node, 5 node, or 50 node cluster, you have to do the pre-checks so that we can fail early and we can check the things, rectify the things, and then proceed to the next steps. And Robin provides a utility, or SimCloud platform provides a utility which can help you to actually check all the prerequisites if they are met in these servers or not. Once pre-checks are done, now it's time to do a master bootstrapping. So we are going to tell that this node will going to be the master server for us, which means the Robin platform or the SimCloud platform will going to install all of the components. So it will be Kubernetes plus plus plus. That plus 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 are all the features which SimCloud platform will going to deploy for us. Once this is done, we need to activate our SimCloud platform. Now we need to register for a trial license, and then we need to activate our master node. Once the license is activated, you will be able to see the master is up and running. And then we will move our focus to the worker node. We are going to do the bootstrapping of the worker node, and we are going to add our worker node to our master node. And once done, we are just going to check the status of our cluster. And again, we are not going to use kubectl because you all people are aware of kubectl. We are going to introduce a new command called Robin. So Robin is actually a CLI as well, which will going to help you to do whatever you wanted to do on SymCloud platform. So we are going to run Robin host list, which is equivalent to kubectl get nodes. And if everything goes right, we are going to have our 2 node cluster up and running. So these all are the steps which we have to follow one by one in sequence. There are a couple of tips which I'm going to demonstrate you and tell you when I'm going to do the setup. Reason being because I struggled initially to find out the tips which were missing in some portions of the documentation. So I have noted them and I'll pinpoint them to you so that in case you people want to deploy your SymCloud platform with a trial license, it will be very easy for you to follow those tips and install the things then and there. Now, without further delay, what I'm going to do is I'm going to do the entire setup in front of you, right? So there might be some places where the servers are getting created, so I might be quiet, or now I'm going to show you multiple things and explain you multiple other concepts during that time. But let's get started. So what I'm going to do is I'm going to do everything from scratch. There is nothing which is as of now up and running. So I'm going to do everything in front of you right here. I'm going to use AWS. Now, if you see here, there is no server which is up and running. Now, there are a couple of servers which are in stopped state. If you see here, there are a couple of Kubernetes servers. There is one test cluster of Robin as well here, right? Deepti have used Thinknyx demo to demonstrate you how Docker ecosystem works. So what I'm going to do is I'm going to create 2 servers. So I'm going to give it a name called SymCloud Platform. Scroll down. What I have done, I have actually created one AMI and I have already downloaded the binaries. Otherwise, it will unnecessarily going to take 15 minutes for us to download everything. So I have created one AMI in which I have just put the binaries of SymCloud platform. Nothing else have been done. So I'll take that. If you see here, I have given it a name called CentOS patch. You can take any CentOS, RHEL or Rocky Linux, and on top of that, you can download that, but it will unnecessarily going to take 15 minutes. So just to save time, I have already placed those binaries in this AMI. Scroll down, instance type. So I'm going to carefully choose, I think it should be C4 2x large. So I'm going to take 8 CPUs, which is mandatory, and I'm going to use 15 GB of memory. So I'll take this. Scroll down, key pair. Now the password is enabled. Still, just to prefer things, I'm just taking a key pair called PB demo. And if you come here, I'm going to use existing security groups. Now, just to keep things simple, I'm going to use a default security group in which I have allowed all the traffic. This should not be the case when we people are doing anything in production. Reason being, all open is not secure, right? But just to demonstrate this, I have created this default security group where all of the traffic has been allowed. If you see this storage, instead of 30 GB, what I'm going to do is I'm going to take 100 GB. So I'm going to create a root disk of 100 GB. Reason being, I'm going to demonstrate you to create something called file collections, which is one of the concepts in Robin. So initially, I'm taking 100 GB of root disk. But there are specific storage requirements. To follow the best practices, we should follow that, which I am going to demonstrate you when I'm going to tell you the things from the documentation. Just to keep things simple, I'm taking one root disk of 100 GB. Come here, I'm going to create 2 servers, right? I'm taking ephemeral IP at present point in time. In production, you should have EIPs. It should be always a persistent IP. Come down, launch instances. It will actually going to create 2 servers for us. So I'll come here, I'll filter it out with state equal to running or state equal to pending. See here, both of the servers are coming up. So now let me change it a bit. Let me give it a name called master so that we can recognize it. And let me give it a name called worker. So now our servers are up and running. So we have master and we have worker. Let us access our master server first. So I'll come back, come to a terminal, SSH. I'm going to do everything with root. Yes. You can do the login via a key. I have enabled the password, so it will prompt me the password soon. Should not take this much time. Anyways, till the time it is coming up, let me take the worker as well. Copy it, come back. Oh, it's coming. Let me put in. See here, this is my master. What I'll do is just to distinguish the things, I'm going to open a terminal and I'm going to give it a different profile. Let's say basic. So this will be white screen. So white screen will going to be our worker and black screen will going to be our master. So that you people should not get confused that what I'm running on master and what I'm running on worker. So I'll do SSH to the worker as well. Yes. Password, enter. Here we go. So we have master. Now it's very difficult to recognize things with this name because these are provided by Amazon. Every cloud is having their own way of giving the initial names, right? So I will going to change it. Host name, CTL, set hyphen host name, and I'm going to give it a name called, let's say, Thinknyx master. Bash changed. Likewise, I'm going to change the things for my worker as well. Hostname, CTL, set hyphen hostname, Thinknyx worker. Done. Bash, all done. So I'm having two servers, one with a name called master and one with a name called worker. Now, couple of things which we should remember. Uname hyphen R or uname hyphen A, whatever you wanted to run. Now, if you see here, whenever you are using CentOS or Red Hat or Rocky Linux, you need to make sure that you should have a specific patch. So the minimum patch is 1062. So if you are not having or you are having the kernel version less than 1062, you have to do yum-y update because that's the minimum level of kernel which is required to install SymCloud platform. Now in both of our servers, I have already applied that to again save 5-10 minutes. So if you see here 1160, even with 1160, SymCloud platform can support the NUMA based architecture nodes as well. Now, I'll come back. Second thing, I want my master to talk to my worker and my worker to talk to my master. Now, I'm not having any DNS in this particular session. Now, what I should do? I'm going to do a local resolution. So what I'm going to do is IP EDDR. This is my private IP. I'm going to take it and I'm going to put it in the etc hosts file for both of the servers. Come, Thinknyx master. Likewise, take the IP of your worker, come back, come, come and put it Thinknyx worker. Now in production, you need not to do this. Reason being, you're always going to have a DNS. So you just need to configure your etcresolve.conf. That's it. Your server will go to DNS. DNS will do all the reverse lookups for you, and going to take you to the other server. But in our case, as we are not having DNS, so I'm just doing a local resolution of host. Come back, come back here, do the same thing with your worker as well. So etc hosts, come, paste your things. Let me copy it. Cat etc hosts, come here, copy. I'm using private IPs just to make the things a little more secure. No other way. Otherwise, you could have used the EIPs as well. Done, back. So if I do ping Thinknyx master, enter, see here, it is resolving. I'll do Control C here, come back. Let me clear a screen of my master. Ping, Thinknyx, worker, enter, see here, done. So host resolution is also working. What's next? Now we need to disable firewall. So there is no firewall by default in these servers. If you are having firewall, make sure systemctl stop firewall D, systemctl disable firewall D. Likewise, your SC Linux should be disabled. So if I do get enforce, enter, see here, it is already disabled. If it is not disabled, what you need to do is set enforce 0. This will disable it for this current session. And once that is done, you can just edit this file etc sclinux and config. Come here, just put disable and reboot your system. Always remember, unless and until you will not reboot your system, it will not show you disabled. It will show you permissive. And if you try to install SymCloud platform, it will show you your SC Linux is not disabled. Hence, reboot plays a vital role if you are changing your SC Linux ecosystem. Same thing, if I go to my worker, let me clear a screen. If I do get and force enter, it is already disabled. Next, swap. Again, if I do free hyphen M, enter, see this, there is no swap. Even you can do cat, etc, fstab, enter, and you will be able to see something called swap under the third section of this file. So if you see here, there is only one file system of XFS style. So there is no swap. Obviously, when you talk about cloud, if you want to put swap, you need to pay for that. But when you talk about on-prem, you will always see swap. Make sure swap is disabled. Now, this is not because of SymCloud platform. Trust me, this is all because it's a requirement of Kubernetes. If you enable swap, kubelet will not work. You will start showing issues. I have faced this issue with multiple customers. They always call us at night and say the kubelet is not coming up. Why? Because they have rebooted their worker node, and in worker node they haven't disabled the swap line in etcfs tab. Because of that, swap came up, and because of that, kubelet was not coming up. So what you need to do is just hash it out. Systemctl restart kubelet, all comes up. So this is a Kubernetes requirement actually, right? So that your kubelet should function correctly. So I'll just clear the screen again from my master. Same thing is there in the worker as well. So if I do free hyphen m, you will be able to see there is no swap. And we are having 15 GB memory allocated to it. Even if I do nproc, you will be able to see there are 8 CPUs. Nproc means number of processors. So our compute is also good. Next is NTP. Now, as I'm using CentOS 7, so I'm using NTP. Otherwise, I would have gone with Cronity rather. So what I'm going to do is yum install NTP enter. So it will actually going to install NTP for me. NTP is network time protocol. Again, if you are coming from the old school like me, so it's one of the most important services on any Unix based system or Unix based kernel. You talk about HP Unix, you talk about Solaris, AIX, or any flavor of Linux. If you want your applications to be in sync, you have to have network time protocol in place. Yes, done. Systemctl start NTPD and then systemctl enable NTPD. Done. Systemctl status NTPD. Enter. See this. Active, enabled, up from last 5 seconds. Perfect. Go to the worker and do the same thing because prerequisites are required for all servers, which will going to be a part of our SymCloud platform. Yum install NTP. Meanwhile, it is doing it. Let me copy this command so that we can just paste it to start and enable it. Come back here, refreshing the repositories, identifying it is available in one of the repositories, downloading NTP package. Yes, perfect. Enter systemctl status NTPD. Done. See here, active, enable, up from 5 seconds. Right? So all things so far have been done on both servers. Next important thing. Now, we need to enable IPv4 forwarding. Now, in most of the organizations, when they create their golden images, they put this parameter inbuilt. Now, when we are taking the image directly from the vendor, there might be a possibility it's not there. If I do sys ctl -p, you will see there is nothing. It means I need to enable it. It's a kernel parameter actually. So what I need to do is etc sysctl dot d, and then you will be having 99-sysctl.conf file. Just open it, go to the last, come here, and you just put net.ipv4.ip_forward, and then put this value 1. Again, this is one of the prerequisites for your Kubernetes as well. Even if you people are using Cryo as a container runtime interface in Kubernetes, you have to put this setting. Otherwise, the pods communication will not going to work. So this is again one of the prerequisites which is required for native Kubernetes as well. Save it, run sysctl-p, and you are going to see this has been taken care by kernel now. So it is in effect. Same thing I'm just going to do in the worker node as well. Come back, enter, scroll down, come back, copy this parameter, net IPv4 IP_forward. Let me see if I have not done any typos. Yeah, it's looking good. Sysctl-p. Perfect. Most of the things are done. Now we need to open the ports. So when we talk about open the ports, I'll again go back here. If I come to the security, I'll just show you that these servers have been a part of this particular service group, sorry, security group, sorry. And if you come down here, and if I show you, I have allowed all the traffic for this demo. See this. All IPv4 traffic is allowed. See this, all. Now it should not be the case in production, as I'm saying you again. We should always allow some specific ports. And what all those ports are, when the installation will be going on, because it will take 15 minutes, I'll take you through the documentation and explain you what all those ports are, or at least tell you that these are the ports which you have to open. I'll again come back to EC2, come back to our master server. Now what we need to do is we need to have the binaries with us. Now question comes, how can I be able to get the binaries? You just need to be in touch with the support team of Rakuten people. That's it. So you need to just approach SymCloud platform people, and they will going to provide you the link to download the binaries which are required. Actually, when you're going with a manual installation, there are three major files which are required. And when you talk about the automatic one, there is only one binary which is called Go Robin. So as I'm going with manual, now if I go to root, I have already created a folder called Robin. So if I go inside it and do ls, see here, this is the tar file which the SymCloud platform people will provide to you. So they provided the second last stable version to me, and I untarred it. I go inside it, and I'm going to see three things here. See these three things. Now this is Robin images. Robin will going to create, or SymCloud platform will going to create multiple containers, multiple pods. All those images are inside it. All Kubernetes images are inside it. And this is actually a command. This script is actually a command. And this is something which we are going to use. Right? And if you are using, if I do cat etc CentOS release, see here, CentOS 7 is there. If you are having enterprise Linux 8, CentOS 8 or Red Hat 8, you have to use this script. Some changes have been done because the operating system has been changed. Otherwise, the purpose of these two scripts is same. So this is like a utility. Even in future, they might convert this into a utility as well, which is just like a normal command. Now what we need to do, our prerequisites are all met. Now, if I go back to the slides, just to show you, go back, see here, all of these prerequisites are met. Now, second thing is pre-checks. Come back. Now, what I'm going to do, I'm just going to clear a screen, ls, enter. I'm not going to copy paste anything. We'll see the things from here. What you need to do is you need not to remember anything. Just copy this / help, and it will going to give you all the options which you people can use. Enter. See this. Go up. It will tell you what are server options, etc. See this. If you wanted to install master, you need to do this. If you wanted to install worker, you need to do this. If you wanted to do the pre-checks, see here, do this. So I just need to run this. That's it. And it will tell us what to fix in case there are issues. So it will show us pass, warning, failed. and basis or error, and basis on that we need to fix the things before we move to the next step. So let us do it. I'll copy this. Robin install k8s.sh pre-check. See here, it started doing it. It will take couple of minutes, right? 2 minutes, and it will actually going to show everything to us. What all checks have been passed, what all checks have been failed, and basis on that, whatever we can fix, we will fix it. And whatever we wanted to ignore, we will ignore it. Right? So let us see what it will show. Meanwhile, we are running it on master. Same thing, let me run it on a worker as well, because our worker should also pass all the pre-checks. Again, same place. I have kept those binaries inside root directory. Robin, go, Robin tar, ls, script, pre-check, enter. See here, we are running it on a worker as well. Let's go back to the master and see what happens. See here. Wow, it got completed. See this. Done, 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 done. Very good. It's always good to see passed, right? Now, if you see here, as I mentioned you, if I go back to slides again, see this. Specific file systems and directories, specific storage requirements. You will see this in the pre-checks. See here, it is saying where lib docker is not a partition. It means as best practice, you should always have where lib docker as a separate partition and a separate file system. Likewise, if you come here, you are going to see KVM and NUMA nodes. Now I'll tell you one thing which probably surprise you, because this thing is not available in any of the other Kubernetes enterprise platforms. Now you will be surprised to know that you can even create a VM on top of SymCloud platform. Again, I'm saying it. You can create a VM on top of SymCloud platform. So you can run VMs as well as your containerized applications on a same platform. It means you can think of this as a virtualization environment as well. But there are certain prerequisites to it. The KVM should be enabled, right? And NUMA nodes. So we are not having NUMA nodes because NUMA nodes is always having specific requirements and architectures to that. Non-uniform memory access, I think this is a full form of NUMA, right? So it is saying there is no NUMA NIC available. Warnings ignored. PCI through pass again required for VM creations. We don't need it. Come down, see this. Now this is Robin home directory /home/Robin DS. Inside that you should have where logs, where all of the logs of Robin should be there. You should have where crash. In case your SymCloud platform is crashed, all of the dump will be created inside it. Now internally, SymCloud platform uses PostgreSQL database and it put all the things related to it inside home Robin DS where lib PSQL. So these all should be separate file systems. Again, this is coming from the old school of Unix. If you are having applications, they should always reside on separate file systems or separate disks. So that in case one of the disks got crashed or root got crashed, you should not lose your data. So Robin or SymCloud platform is also recommending and suggesting us to stick to the ground roots. Scroll down, see here, network services, this you can ignore. Come here, partitions, again ignore. Come here, see this. For driver, use Robin storage. Once we install the things, this should go. Come down here. Now these all are the warnings, and out of them, couple of warnings we can remove. Example, mkdir-p. I will not create a partition, but I can at least create a folder. So that some of the warnings should go, because I'm not going to have a big cluster wherein I'm having multiple disks and file systems. So I'll just give you a workaround to create these directories. Enter, done. Right now, if I run it again, right, let it get run. And meanwhile, I'm going to complete the same thing in the worker as well. Come here, same things. See this. Similar kind of things are there in the worker as well, right? So scroll down, all similar kind of a thing. I'll do mkdir done, run the pre-checks here as well and see what all difference it will do. So I'll come back again and And see here, see the things are less now. The warnings are less. If I go up, there were more warnings, right? This folder, 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 these all things are gone. It is just showing not a partition, not a partition, not because we are not having a partition here, right? See this. Again, there is one more thing. If you closely see here, there is one more line coming here. No drives available for storage. Now, when the setup will be ready, when I'm going to go to the terminologies, I'll explain you something called roles, right? Node roles. That is where I'll tell you something called manager, compute, and storage. And this will going to make more sense then. But in order to mitigate it, what we need to do is we need to allocate some storage to dedicated nodes in SymCloud platform. And those nodes will act as storage nodes. So what I can do is, I think we can do it here itself in this particular part itself. I'm going to create two more disks now, two more separate disks. So I'll again going to come to volumes. Let us come here, it equal to running, close this. So our two servers are here. So I'll come here to the volume and I'm going to create two separate volumes of 50 GB. And I'm going to allocate it to master as well as worker. Now, why? Because just for your reference, one for file collection and one for PV and PVC. Now, what are all these things? When we come to the terminologies, I'll explain you in depth. But for the time being, just to mitigate the storage part, I'm going to add or create 50 GB disk. So 50 GB, come here. These servers are running in US East 1B. So I'm going to create it in the same zone. Scroll down. So I'll give it a name called SymCloud Master Disk 1 so that I can recognize it. Create a volume. I'm going to create another volume of 50 GB US East 1B. Come here, name SymCloud Worker Disk 1. Come here, create volume. Now you will be able to see two volumes. This again, before I allocate it, I'll just go back. I'll do ls blk. See here, there is only one disk of 100 GB. Even if I do f disk -l, there is only one disk. So I'm just going to attach one more disk to these servers, master as well as worker. One additional 50 GB disk, which I'm going to use as a storage. Come back, master disk, action, attach, master disk with master server. See here. Come here, attach volume. Likewise, worker, select the disk, action, attach volume with worker, come, attach. Scroll back to the things. Better you can do rescan scuzzy in case you want. Always a best practice to update the tree, the dev tree, right? Come down, lsblk, see one disk came of 50 GB. Likewise, if I come here, lsblk or fdisk, they're going to see a disk is available here. Now, if I come back here to my master, let me clear a screen and I do the pre-checks again, just to demonstrate you that that error will go. So it will take 1 minute and it will do the things for us. See this? Now there are more passed as compared to warnings. Scroll down, see here, checking more things and everything is getting passed. Come here. Now, if you see here, that portion is gone. Now it is showing something else. It is showing WWN is not there, device full path is not there. So once we configure the disk, this error will also go. But now we have a disk which we can use as a storage for persistent data. Now, prerequisites done. Again, come back to the slides. Step number 2 is done. Step number 3 is master bootstrapping. Now, when you talk about master bootstrapping, there are multiple things which we need to do. Now again, let me tell you what all things we need to do. Come here, let me clear a screen. Again, I'll do this help. Enter. Go up. Now we need to use this thing. See here, set up a new Kubernetes master Robin server node. So we are going to create a master and Robin server node. Now this need multiple things. If you come down, you scroll down a bit, see these options. Now you need to give a username. You need to give a password. These are mandatory fields. Now, if you closely see these two things, these are the files which we have downloaded already. So this is Kubernetes image files, and these are Robin image files. Now, if you see here, if you are specifically using uh, a different environment, you people have to give something called host type. In our case, it will going to be EC2. Right now, there are a couple of more things on AWS, especially. If you see here, master or Robin server options. Out of them, access key and secret key. How can this node will be going to connect to the AWS to do the configurations if required at cloud level? It means we need to give access key and secret key to validate our cloud. Right? Again, if you scroll little up, we people were getting certain warnings. If you want to ignore these warnings, we people have to use this flag called ignore warnings as well. Now there is one more thing. And trust me, I struggled for that for at least 7 to 8 nights to figure it out. And that thing is because we are using cloud, we have to give another thing called public IP. If you scroll down, you will be able to see something called public IP. Otherwise, it will take a private IP, and private IP will not be accessible from outside because it is internal and you will not be able to get the UI. Hence, you have to give the persistent IP, public IP, or in case you are having a public hostname, you can give that also. Or if you are having any accessible VIP from outside, you can give that as well here. But in our case, in AWS, in this demonstration, I'm going to use an option called public IP. That's it. We need not to give anything else. So now what I'm going to do is I'm going to start the installation of our server, our Robin master, our SymCloud platform master node. Dot slash Robin this. So what I need to do is I'm creating a server hyphen username. You can give any username here. Example, I'm giving Thinknyx. Then hyphen password. You can give any password of your choice because it will going to create a admin tenant for us in this case. So I'm just going to give, let's say Thinknyx 123. Now hyphen Robin. I think it was Robin. Let me do copy the things from the options from here. Else it will be difficult to remember them. Let me. So we have given username, we have given password, we have this. Robin image archives. So I'll copy, come back here. This. And this is the things which are already available in our downloads. Robin image tar. And then we are going to have K8's image archive. Copy, come back equal to K8's image. Now hyphen host hyphen type, which will going to be EC2. And then hyphen access hyphen key. Now, what I'm going to do is I'm temporarily going to create the access key and secret keys in front of you so that you should see everything from ground up. So I'm going to come back. IAM, come here, manage access keys, come down. If you see here, I'm already having two keys. Let me delete this key because it will not allow me to create more than two keys. Delete. Uh, come, come, come here, create access key. I understand it's not good to create access key with all permissions, but I have no choice. See this access key. So I'll copy this access key, come here, come here. Then hyphen hyphen secret hyphen key. So I'll put this secret key in a while, right? And then again hyphen hyphen ignore hyphen warnings, right? And then hyphen hyphen public hyphen IP equal to the public IP, which is the temporary IP of our master. I haven't created EIP, it's a ephemeral IP, this one. Come back, come back, paste it. So we are having server installation, username, password. These are the Robin images. These are the Kubernetes images. The host type is EC2, access key is this, and finally the secret key, which I am going to take from my here. So I'll copy this, come back, enter. See here, the installation started. The installation will actually going to do the pre-checks first, and then it will proceed further. I'll show you it. And till that time, I'm not going to do anything in worker. Let our master to be up and running, because if there will be any issues, we are actually going to mitigate them then and there. Right? So let us wait, see this. It is actually doing a pre-checks first. All of the pre-checks are passed. If there is any error in the pre-checks, things will not work. And if you see here, it started doing the installation now. So there are several steps which it will actually going to perform now. And this particular section will going to take at least 10 to 15 minutes now. Now, what we are going to do in those 10 to 15 minutes, we are actually going to explore multiple things. Thing number one, whatever I told you, I'm sure it's not possible to remember everything by just this slide. Now, what I'm going to do is I'm actually going to show you that this entire slide deck is prepared by referring the official Robin documentation. So now when you talk about the documentation, come back docs.robin.com. Mm. Docs.robin.io. I'm sorry, it's not .com, it's docs.robin.io. Right? Now, if you see here, you are having CNS and you are having CNP. These are two different products. Even there is another product called MDCap. We are definitely going to come up with our next conference on cloud native storage by which is provided by Rakuten Symcloud. But at present point in time, we are going to focus on cloud native platform. So this Robin cloud native platform is actually Symcloud platform now. And if you see here, these are the different versions. And out of them, we are actually doing this one, right? 5.4 is the latest one. 5.3 is the second last, right? So I'm going to go to 5.3, which is the one we are using. And hence it's always good to go to the documentation of the same. Then just click on read documentation. It will actually going to take you to the entire documentation of Robin platform, which is nothing, which is actually SymCloud platform documentation. Now, if you come to this Robin platform overview, go through it. Now, if you see here, this is a high level capability workflow for Robin's product or for SymCloud platform. So you get application manager, you get networking, you get Kubernetes engine, you get app aware storage, you get multiple other things bundled into a single enterprise offering by SymCloud. Scroll down, see here, there are lots of capabilities. Now, when you talk about certain capabilities, number one, you can install SymCloud platform on any environment. It can be bare metal, it can be cloud, it can be VMware, it can be Hyper-V, it can be anything. Second good thing, see this. This is very, very good actually. You can run containers or you can run VMs. Wow. One software and I can manage VMs as well as containers. So you can download your QCOW2 images, put them inside the repositories, and you can just spin up a VM on top of your SymCloud platform. Really good, right? Apart from that, multiple other things. Scroll down, see this. Placement policies, which means you have many options via which you can put things on a server or you can avoid putting things on a server. So you can It supports something called node policies, rack policies, lab policies, data center placement policies, and many other things. NumaWare, again, the advanced thing which is missing in other enterprise Kubernetes platforms. All native Kubernetes affinity, anti-affinity rules are absolutely, applicable and acceptable when it comes to SymCloud platform. Now, one great thing, data. When you talk about Kubernetes, one of the challenges stateful sets. The applications where you want to retain the data, the ongoing data, especially networks, especially databases, especially messaging services, especially queuing services. Now you have to have a robust solution for that. Ironically, Kubernetes doesn't come with any inbuilt storage solution. You people have to rely upon CSIs. And when you talk about CSIs, Robin Cloud native storage is one of the topmost storage used in the industry. Relying now, when you talk about the reliability, just to let you know, it is actually the preferred storage for Google Anthos as well. Now, Google platform, especially in container ecosystem, is highly relying upon the storage of SymCloud or Rakuten. Next, when you come network, now again, whenever we talk about networking is very crucial, very crucial. And it doesn't come out of the box with Kubernetes. Now, again, you need to rely upon third-party CNIs. When you talk about SymCloud platform, you get multiple networking features inbuilt. You talk about Calico, the overlay network. You talk about SRIOB. You talk about OVS. You talk about Multus. You talk about persistent IPs to your pods. If pod is getting crashed, new pod is coming up, same IP should get allocated. Wow, these all things you can do using the networking capabilities of SymCloud platform. And trust me, it's one of the gifts for telecom. Because in network, in telecom, you are very much bound to the IPs. And hence, that's the reason SymCloud platform is a default choice for telco industry today. Application deployment and lifecycle management. Now, when you talk about Kubernetes, people talk about native Kubernetes approach, customize, Helm charts. Trust me, you are having something called Robin bundles. Now, when there was no Kubernetes, Robin was having their own orchestrator. And this is something which I got to know one of the very old member of the Robin ecosystem. And I was actually surprised to know that when people were talking or thinking about orchestration, Robin was having their own orchestrator. And that point in time in 2010, 2011, they have created something called Robin Bundle Framework. It means a packaging ecosystem via which you can install applications on Robin platform. Wow. And I'm going to demonstrate that in application deployment. So you can have a single click application deployment. You can scale them. You can delete things. You can take a snapshot. You can clone them. There are multiple features, and UI is simple, super simple. So you go through it, it will actually going to help you to understand what all capabilities SymCloud platform offers to us. Now, installation, see this. I was talking about prerequisites. Trust me, I was not bringing it from here and there. It is actually coming from this particular page. Now, if you see here, there are many prerequisites. Now, this part, I would strongly suggest you not to focus on 4 GB, at least 8 GB should be there for minimum cluster. And if you are actually wanting to do some application deployment and wanted to do a real useful testing, my suggestion is to go with 8 to 16 GB. Apart from that, everything else remains same. See this. Oracle, CentOS, Red Hat, even Oracle Linux is supported, Rocky Linux is supported. This is what I was talking about, minimum kernel level. Scroll down, see this. Firewall should be disabled, SE Linux should be disabled, NTP should be up. Swap should be disabled. Now see this file systems. Scroll down. This is what I was actually talking about. See here. Varlib Docker, Varlib Robin, home Robin DS, home Robin DS var log, var crash, var lib PG SQL. Now, if you see here, you have to have a partition for this. And those partitions should have, see this, 50 GB, 20 GB, 20 GB, approximately 55 GB. See here, 100 GB, 80 GB. So I was not using all these things. That's the reason I just created directories. Because if you are doing a POC or a testing, you need not to have this, right? Hence, you can skip it by just creating directories. But in prod, highly recommended to have this as a separate partition of or separate file systems. Scroll down, ports, see this. These all are the ports. Many of these ports you will see are same as that of your Kubernetes. Now, this is etcd, this is again UI access, this is your kube API server, and rest of these are related to Robin. And if you see here, 10250 is kubelet. Now, this is important one, 29443. Now, this is something which most of the developers loves actually. Now, this will actually going to give you UI. So 29443 is a UI for Robin, right? Robin dashboard, rather, I should say. Now, if you come little down, see this, I just wanted to show you, see here. Now, I was saying that you can install SymCloud platform using manual approach or using automated approach. See here, this is actually documented here. So either you can use manual installation or you can use automated installation using GoRobin. And the ways are given in downwards in the documentation. So I'll go a little up here. See this. So you can follow whatever documentation you want to follow with reference to your environment. So I'll just quickly jump into AWS. See here. So you can have a manual installation or automated installation. So I'll just click on this manual installation and show you one more thing. See this. You are having non-HA based installation. And if you scroll down, you are having HA based installation. HA means again, following the quorum. So we will be having minimum 3 masters and rest of the worker nodes. When you talk about non-HA, we are having a single point of failure, which is a single master. So we are actually using non-HA here. Now, if you see here, it is doing the same thing. .sh server, username, password, Robin images, Kubernetes images, host type, access key, secret key. Now, if you see here, it is not showing hyphen public IP or hyphen ignore warnings. And hence, if you are new to it, those 2 pointers will going to help you out. Otherwise, this installation will fail. This is what I have learned by investing a lot of my time. Trust me, I did more than 10 time installation to figure it out why it is not working. Right? So again, I'm pretty much sure this will be changed. I will raise a PR with the Rakuten team so that they can add those 2 options, at least in the notes. Right? Now, see here, this is what all is going on. All these things are going on. Now I'll come back and see what's the status. See here, the Kubernetes images have been loaded. The Robin images are getting loaded. It means it will again, it will actually going to take approximately 5 minutes more to have this setup up and running. So till that time, what I'm going to do is I'm actually going to tell you a couple of more things, which probably can help you to understand many other things. So I'll just come to this screen and I'll tell you what Robin offers to us. Now, when we talk about any software, so we always talk about something called Kubernetes. Now, when you talk about Kubernetes, Kubernetes is an orchestrator, but there are multiple things which Kubernetes required. Number one, Kubernetes will not going to create containers for us. Kubernetes is not a container creation software. Kubernetes is a container management software. But the heavy lifting of container creation will be taken care by someone else. And if you people are using native Kubernetes, you people have to integrate something called CRI. Example, Docker. You need to figure out what is a compatible version of Kubernetes with Docker, install that, and then only you will be able to install Kubernetes. Likewise, when you talk about Kubernetes, Kubernetes will not going to come up with any network or network software. Now it will going to be your responsibility to figure out what suits your environment, right? And basis on that, you need to understand that underlying technology and have to install it and integrate it with Kubernetes. Many companies are struggling because of this. Again, multiple examples are there. I'm just writing Calico here because they are the industry leaders when it comes to um, CNIs. You have Weave, you have Flannel, you have Knitter, and there are many other. Cilium. Likewise, Kubernetes, when it comes to stateless applications, okay, no problem, you can use it. But what about data? What about the applications where data is most critical? When we are talking about moving towards containers, we cannot just put our web servers on containers. It should be the entire ecosystem. And we always talk about microservices. And when we talk about microservices, we are talking about a lightweight database. And when we are talking about a lightweight database, definitely we don't want to run it on a bare VM because it will going to kill a lot of resources unnecessarily. And hence, we need a way wherein we can host our databases on top of Kubernetes as a pod, as a container. But for that, again, CSI, you need a storage. You need a storage. And here I'll always talk about Robin storage. I always talk about something called CNS, Cloud Native Storage by Robin. Now there are other options also. You have Portworx, you have On That, you have Flocker, right? Um Scale.io, GlusterFS, right? There are many. Now, next thing, you need something called package manager. Now, when you talk about Kubernetes, Kubernetes is all about tens to hundreds of YAML files. If you are giving those YAML files to anyone who is not aware of Kubernetes, he'll just get mad. What to do? I don't know what to do with these YAML files. And hence, it's always good to do a package management. And that package management is actually something which is provided by packaging tools in Kubernetes. Example, you have Helm charts, right? Even some of the companies are using something called Customize. So Customize is little lighter version of Helm, you can say. It helps you to do the things in different environments altogether with a single YAML file. Now, next thing, when you talk about Kubernetes, you always talk about something called monitoring. We have Kubernetes, we have pods, we have services, we have deployments, we have everything up and running. Now, my pod went down. My pod crashed. Some application went down. PV is unreachable. Host is not ready. How can I be able to monitor all such things? Can I use my traditional monitoring softwares to do that? The answer is no. Again, struggle. Again, identify a software integrated with Kubernetes. Now a leader here is Prometheus. You can use it as alerting tool. You can use it as a monitoring tool, which can scrap your metrics, especially when it comes to containerization, and give you something really extraordinary with the help of TSDB. TSDB is time series database. Now we have metrics. My managers, my senior managers, and my top management is not interested in running commands. They are actually interested in looking into useful graphs which can give them the entire visibility in fraction of seconds. How many things are up, how many things are down, what's the total availability percentage. Now again, struggle comes. That struggle is actually being removed using something called dashboards. Again, identify your software. I wanted to use Kibana. I wanted to use Grafana. No problem. Learn it and integrate it and then manage it. Again, struggle. Likewise, alerts. Monitoring is done. Dashboarding is done. Things are down. I wanted to create alerts and notifications. Struggle continues. Identify things, integrate them. Even Grafana gives you something called alerting capabilities, and even Prometheus gives the alerting capabilities. But you need to generate and create, you need to create those alerting mechanisms. Now everything is good. Let's say someday my Kubernetes crashed. Some network outage happened. Because of that, my servers crashed. Everything is down. My production applications were running on top of it. And when I'm bringing my Kubernetes up, things are not coming up. What to do? Either follow the traditional backup and restoration approach, which will always going to be challenging and which cannot assure you that you are going to get everything back. Because VM based approach will not going to work in container based approach. Now again, backup and restoration, snapshots, clones, right, and other things. Find a software. Example, Kasten. Example, Portworx. Example, Robin Cloud Platform or Robin Symcloud Platform. Apart from that, one more thing which I would like to highlight here, RBAC. Now, when you talk about Kubernetes, you are definitely having a RBAC, but that RBAC is not easy. You need to create users out of the box at a OS level. Then you need to start struggling with the things of creating role binding, cluster role bindings for namespace specific permissions and for cluster wide permissions. Then create a complex context file, put the things, give that context file to a user, ask them to check, and then do the things. Not easy. And even it is very painful when you have to integrate your local native Kubernetes RBAC with your AD or LDAP. UI, when you talk about developers, they are not interested in managing Kubernetes platform. Rather, they are more interested in developing their microservices and deploying them on the cluster. How cluster is built, what is running there, how to maintain it, they are least bothered about that. And hence, either give them single command or give them a UI so that they can upload their bundle, click a button, and all done. So when you talk about Kubernetes, there is something called Kubernetes dashboard. But I would strongly suggest you to read the history of that, and especially with a company called Tesla. They used it in, I think, 2017 or 18, and their entire ecosystem got hacked because of the permission issues. So it's not easy to use anything or everything with your Kubernetes. Now think about it. We just talk about Kubernetes and we say Kubernetes is everything, but Kubernetes is not everything. If you really wanted to make the entire platform at least 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then Kubernetes itself 11. If you really wanted to become a Kubernetes expert, these 11 technologies should be in your pocket at least. Then only you can say, I may manage native Kubernetes. Now, companies cannot take a risk of putting all these things as an open source and run their highly critical, telco applications or banking applications or retail applications on such things. No, with dev, it is okay. But with prod or UAT, they cannot take this chance. This is where SymCloud platform will help you. Now, when you talk about these all things, you need not to worry. SymCloud platform, they have actually taken all these things. They have validated that and engineered them so that it can run anywhere on any supported platform. They have CRI, they use Docker. They have CNI, they use multiple CNIs actually. They use Calico, they use OVS, they use SRIOV, DPDK. With networks, I think they are uncomparable with any other enterprise offerings as far as my experience is concerned so far. CSI, they are one of the leaders when it comes to storage, and they use Robin CNS. Packaging tools, they support Helm, and they have something called Robin bundles. So your packaging problem is done. Monitoring, you need not to do anything. There is a concept called metrics. Run one command, automatically your dashboarding, monitoring, everything will be set up. So they use under the hood Prometheus here, the leader. And they use Grafana here. And you can have the complete access to Prometheus and Grafana. I will demonstrate it practically to you. They have a solid event and alert management ecosystem. Even they have something very useful, which is called user audit. Which user have done what? Trust me, it's very difficult to find. But if you are using SymCloud platform and you are doing any nasty things, the administrator will actually catch you out. This user have run this command on this time, on this namespace, on this cluster, and you are gone. So it is very useful. So you have something called user edit. Even they have another thing called, which I'm going to explain it in the terminologies, which can help you to troubleshoot the things. They have things like jobs, they have things like Sherlock, right? With that, you can actually do a lot of troubleshooting yourself, the way we people used to do in traditional Solaris or AIX systems. Backup and restorations. Wow, this is one of the features of SymCloud platform. You have things like snapshots, clones, which you can put on a local cluster and restore it at any point in time. Even you can take it outside cluster and store it in the repositories like S3 bucket, like Azure Blob, like Google Cloud Storage. And those things you can actually store as a backup or backup archivals for longer duration. RBAC, wow, they have a concept of something called tenants, user, tenants, tenant roles, and user capabilities. Wow, if you do that, RBAC is super simple. UI, one of the most simplified UIs I ever come across when it comes to enterprise Kubernetes. If I compare it with OpenShift or Tanzu or any other flavor. So MKE, or which was Docker Enterprise in the earlier days, and Robin. I think these two are the most simplified UIs when it comes to a user level experience. Now, what Robin platform does, they actually bundle this entire ecosystem together, and they put few more things, plus plus, and those plus plus things are RCM. RCM stands for Robin Control Manager, right? And then they have something called file server. In order to store your images, in order to store your bundles, they have something called file collection. And that is actually being taken care by a service called file service or file server service. Likewise, when you talk about these events and alerts, they have something called event service. So these three specific components are running in addition to whatever is running here. Right? So all these things combined together, and what you are going to get? You are going to get SymCloud platform. If anything is not running in production, you need not to worry. Raise a case with SymCloud team and they are going to assist you. So you are safe. Your applications are safe. And they are always having a solution wherein you can actually quickly roll back the things to the older versions to avoid any downtime in your production. Now question comes, Yogesh, you are saying it, but can you prove this? Can you prove they are using Docker, Calico, or Prometheus or any other thing? Of course, I can prove that. And what I'm going to do is I'm actually going to go to the documentation again. When you scroll down, you will be able to see something called release notes. Scroll here, just click on it, and you're going to see everything. See this. Now, when you talk about the first 5.3.11 version, 10th November 2021, when it was released, scroll down. We have installed the latest one because they installed or given multiple patches to it. Come up. See this. 19th June 2022. So this was the last 5.3.11 version they released. See this. This was the Kubernetes version, Docker, Prometheus. Now these all are Prometheus related things, Node Exporter and Prometheus adapter. They used Calico, they used ingress controller, HA proxy. Obviously, L7 load balancing is required. They have used internally PostgreSQL where they store everything, and see they have used Grafana. You need not to worry about compatibility. Their engineering team have engineered this solution for you. Right, everyone? Now come back, come back. Wow, see this. Amazing. Our system is ready. See here, 29443. Now, before we access our things, what I'm going to do is let me kickstart the installation of a worker also. Then I'm going to do the licensing just to avoid time because we are already running out of time. I'm having just 15-20 minutes more. And now what I'm going to do is I'm going to install worker. Now, in order to install worker, it's again super simple. What I need to do is same thing, /Robin. Instead of server, if I do hyphen help, you are going to, it's .sh, my bad. What you need to do is you need to use something called agent. If you come up here, see this, join an existing Kubernetes master agent. Now, if you come here to the PPTs, now I'm going to step number 5 called worker bootstrapping. Quickly come, I'm going to come here quickly. Let me copy whatever is possible from this command. Right. So first of all, I'll copy this entire. Clear the screen. And I'll remove, we don't need public IP. We don't need access key and secret keys because that is required only to bootstrap your master. We need host type, we need archive images for Kubernetes, we need archive images for Robin, we need a username and password. Here is something extra which we need. So first of all, replace this server. We are not going to bootstrap a master, we are going to bootstrap agent. And with agent, you just need to give one thing, hyphen server. The master node. So if you come back, this is my master node, 172.31 this. This is the private IP. If I do cat etc host, you will see this. See, this is what, see here. This is, sorry, this is the 104. So I'll just copy this, come back. I'll give server equal to this. Now this will actually going to do the same thing, but it will not going to install any master components here like RCM, file server, or event server. It will just going to install the things which are required for the worker nodes. So enter, and it will actually, okay, so I am, so if you see here, I missed dot here, and hence it is showing no such file or directory, /, or let me do enter 2-3 times. Copy this entirely, /bank. See here. It started doing the things now. Right now, next thing is if I come here now, the bootstrapping of worker is started. I'll come back to the master. Now, if you see here, master is giving me the UI is available here. So this is my private IP. I'll replace this private IP with public IP. But before that, I'll show you a couple of things. If I do Robin host list, see here, you're not logged in as user and you're going to see your cluster is not activated. Now I'll try to log in with a user. Robin login, username Thinknyx, hyphen password equal to Thinknyx123. Enter. See here. It is saying not authorized to perform this operation. Hyphen password equal to Thinknyx123. Robin login. We have given the same password, right? Thinknyx123. Perfect. If you see here, unable to log in with the credentials, something is wrong. Robin login hyphen help. So Robin login hyphen password Thinknyx123. Username is Thinknyx. See here, user Thinknyx is logged into this. Maybe I have done some typo. Robin login password equal to think, and see this. The password was wrong. It was a typo. NXY. It should be NYX. See this. Right? I logged in. Right now I am authorized and authenticated user. But if you see here, I'm not having a license. Now we need to activate the license first. So what I'm going to do is copy this, go back to a browser, and I'll request for a license. See here, I'll say sign in. I'll add, let's say support at thinknyx.com, my ID, my alias ID, one of So if you see here, it will actually going to give me one uh, thing. So I'll just show you that. Come back, come back. So this is my email. See this? The time is 4:06 and I received this particular link. So I'll copy this. I'll come back, enter, and it will actually going to show me everything. So I'll just say Thinknyx Technologies, sign in. See here, if I say my licenses, it will actually going to show nothing because I haven't taken anything. Now, if you see here, activate. If I click here, it will give me a command called Robin license activate. There are two type of licenses. One is Robin Express, one is Robin Enterprise Trial. So this is lifetime free. And this will obviously will have a couple of more additional features, but it will be a 30 days trial. You can use whatever you want. I'll use this Express one. And what I need to do is I just need to activate this. I'll copy this. This is my ID actually. If you come here, you are going to see same thing here. So I'll just say Robin license activate, come, enter, done. See this. License has been applied successfully. Now comes the magic. Host list. Perfect. See here. This is nothing. This is like cube, CTL, get nodes. Enter. See this. Now I'll clear a screen actually. And what I'll do is I'll Robin host list. And I'll make it little shorter so that I can show you. See here. Let me clear a screen. Come here. See this. So this is the ID of a cluster, name of the host, version, status is ready. See this R pool. This is called resource pool. I'll explain it in a bit. By default, whenever you are going to create a node, it will not going to take any resource pool. Thou Robin platform will going to create a pool called default pool, but you need to allocate it to a node. This is the zone online. If you see this M means master. As I told you earlier, there are roles like manager, like compute, like storage. So at present point in time, this is my master, my manager role. If you see this 8 cores, this 358, 8 means total number of cores, 5 means consumed, 3 means available. GPUs nothing. 14 GB, see this 3 GB is allocated and 10 GB is free. That's the reason the documentation was having 4 GB, right? But it's always good to give more. If you see here, no disk, no disk. Now we have given a disk. I'll show you how to bring a disk here that we are going to use for storage. Sorry. Total number of pods 100. With native Kubernetes, you can have maximum 110 pods on a single server. But when you talk about Robin platform, you can have maximum 100 pods per node. So 100, 27s are already there and 73 are free at present point in time, right? Meanwhile, I'll come back, I'll come here, see here, the installation is still going on, which means the things are still going on. Now, what we are going to do is during the time this is going on, what I'm going to do is I'm going to actually show you the dashboard. So let's go through the dashboard now. I'll come back here. I'll take the public IP, right? I'll go to the slides. So this demo done. So I'm just going to take you to the dashboard walkthrough. The dashboard will look something like this. Now, this is the dashboard where a couple of applications are there. But in our dashboard, I'll show you that how the fresh dashboard looks like. Come back again here, https://ip 29443, enter. So this is a port actually 29443 for UI. Come here, accept and proceed because we are not having the certificates with us and hence HTTPS will not work. See this username, Thinknyx, password, whatever we have given, and I'll say login. If everything is good, it will actually going to take me to a dashboard of Robin. So this is our dashboard. See here. See this? It is saying there is one node, but it is not initialized. So we will mitigate all these things either using, or we can fix all these things by adding roles from GUI as well as CLI. So I'm going to do it using CLI. If you want, I can demonstrate it from GUI as well. Now, let me tell you the major section of this dashboard. The first thing is this dashboard. This dashboard will going to give you the overall status of your cluster. How many nodes are there, which roles they belongs to, what are active alerts, what all are the events, what is the compute resources, etc. available, application details. And if you scroll down, when you enable the metrics, it will going to give you the metrics also. Even you are going to see one pop up here which will show you Grafana. So click there and it will going to take you to the Grafana dashboards also. Right. So on main dashboard, you are going to see the entire high level information of your cluster, including applications, compute, resources, and metrics. Applications. This is a place where you are going to see your applications, installed applications. At present point in time, you are going to see only those applications which you deploy using Robin bundle. So if you are using Helm chart or if you are using native Kubernetes command line, so by default, those things will not come here. Now in the future or upcoming dashboard versions, I'm sure this will going to be there, or there should be a separate section for that. So under this section, you are going to see all those things, right? Now I was talking to you about VMs. Now, when you talk about this image, don't get confused that these images are for container images. No, this section is for your VM QCOW2 images. So this container images means it is VM images, right? So don't get confused. So that's the reason I'm again specifying. This image doesn't mean container images. This image means the image which you can use to create VMs, especially QCOW2 images, which you people deploy on KVMs. Now this repository. Now people sometimes get confused. This repository is for container repository or container register. No, let's say you people are running applications and you want to take a backup of that application and you want to put that backup outside cluster. For that, you people have to configure repositories. So you can create, if I click on register here, see here, AWS S3, Google Cloud, even in the latest version, it supports Azure Blob as well. So you can take a backup of your application and you can put it outside your cluster and you can restore it in case of disaster. Resources. If you come here, you will be able to see two things, namespaces and PDVs. Namespaces, again, these are Robin managed namespaces. These are not Kubernetes namespaces. Whatever you create using Robin, you are going to get it over here. Now, this is a special naming convention. This T means tenant and this U means user. T double zero and then number. U then 5 times zeros and number. So this is tenant ID and this is user ID. So whatever you create using Robin ecosystem, you are going to get here. But if you talk about kubectl namespaces, those will not come by default here. And there is a reason to it. That reason will be more clear when you people are having a good understanding of the RBAC which SymCloud platform offers. So initially it might confuse you, but when you start working on it and you understand the RBAC provided by SymCloud platform, you will really say that this is a good move by Robin. PDVs. Now, when you talk about PDVs, this is called persistent data volumes. Now, these are in Kubernetes, we people know PV and PVC. Now, it is actually a construct of Robin, means it's a terminology which Robin brings in. Now, when you talk about PDVs, you can think of this as a shared file system or shared NAS disk. So this will going to act like your home drive. Let's say you people have created a pod and you have allocated this persistent data volume to it, and anything happened to that pod, you need not to worry. This volume will be there. You can access this volume from other pods. You can allocate it to other pod. You can put things inside it. It means this will going to be uh, not associated with the life cycle management of a pod. And this is actually having many use cases. So think of this as a home directory for a user, which you are creating using Robin. Infrastructure. So you are going to have nodes. So this will actually going to give you the node details. At present point in time, we are having a single node. So it is showing me a single node. See here, click to initialize. to assign a role to it. You are having storage, you are having resource pool, and you are having network. So you are going to get all the resources here. Right? Now scroll down, users. Now, when you talk about users, you are going to get users here, which are local users. Users will going to be a part of a tenant. Tenants can have multiple roles allocated to it. There are three roles actually: super admin, tenant admin, and user, which is there in the slides as well. I'll show you. So you create a user, you allocate it to a tenant, and then you assign a role to it, and then you give permissions to them. So permissions are called capabilities. Roles are called the roles which is mentioned here. Tenant is a tenant. You can think of a group of namespaces in simple layman language, right? Scroll down. Now, when you talk about Copilot, here you are going to see alerts, events, jobs, and user audits. So whatever alerts are there, whatever events it is generating, all those things will be here. So it will be very useful for you to check the things. Now, when you talk about this settings, this is a place where you are going to see the things like registries, file collection, metrics, and license information. So once you click it here, see this. At by default, Docker Hub is registered. You can even add more registries. File collection, a place where your images, where your bundles will get stored. So we are going to create it. License, the details about a license. Metrics, when you enable it, you are going to see a metrics, and here you are going to see something called Grafana. You click there, it will take you to a Grafana dashboard as well. You want to access things from outside, you can take those, you know, those context files or those kubeconfig files from here. So this is the file which you can copy, take outside, install Robin client, and access your cluster from outside. Chargeback. Now, when you talk about enterprise Kubernetes, it's all about giving something for the support. So now when you talk about chargeback, for every application you deploy basis on GPUs, CPU, storage, memory, you people have to pay something. And those all details will be here in the chargeback. Right? So these are the major sections. Now, again, it's impossible to cover everything with a demo in these many hours, but I just give you a high level overview of this. Right? So I'll come back and let us see what's the status. Perfect. See here. Successfully added additional worker node to so my worker is ready. Go back, Robin, host, list, enter. Now, if you see here, if I make it a little small so that you can see everything, see here. Let me clear a screen. Robin host list. Here you go. Master, worker, ready state. See here, no R pool, no R pool. So at present point in time, there is no resource pool allocated to it. Now, if you see here, it is showing synced because we haven't given any role to it yet. Now, we are all set to understand more concepts and deploy our applications. But I think time is running, so I'll quickly go through a couple of terminologies, which I'll explain quickly. Now, when you talk about a resource pool, now resource pool is nothing. It's a construct of Robin, means it's a term which Robin uses. It's nothing. It's grouping of your nodes. Suppose you have three teams and they wanted to use the same SymCloud platform, and every team have their own budgets allocated to it. Basis on that, they have 3344 VMs, so they can club those VMs and they can create something called resource group, and then they can allocate the resources out of that. By default, when you create or install SymCloud platform, you are going to get a default pool, right? Even you can check that using Robin R pool list. So if I come here, let me show you. Let me take it little out and come here. If I do Robin R pool list, you will be able to see here. See this. If you see here, it is showing zero. It is showing zero nodes, zero apps. Everything is zero. But this is a default one. Now, what you can do is you can assign your servers to this. Example, if I do Robin host list, you will be able to see it is showing. Let me make it a little small. I just want you to have a clear visibility. Let me do Robin host list, right? And Robin R pool list. Now, if you see here, nothing is allocated. What I'm going to do is Robin host, and you can do assign our pool. I can do this using GUI as well. Give server names 1, 2, and I'm going to give all the um, I'm just going to give a default pool to all of these nodes, and I'm going to give hyphen hyphen wait default, because what Robin does is Robin actually create one job for everything. If you want to track that job better, you can do hyphen hyphen wait. Enter. See here, the job started. It started doing the things. Things got completed. Now see the difference. Our pool list. It was showing 0, 0. Now it is showing it is allocated to 2 nodes. 2 nodes. 2 out of 2 are in online state. Do Robin host list. Come back. See this. Instead of none, it is showing default to us now. Right? This is one. Come back quickly, the next one. So we have role assignment. Now at present point in time, if you come here and if I do Robin host list, under role section, you will see only M because this is a master manager. But apart from that, there is nothing coming. So when you talk about Robin actually have something called role assignments. There are 3 roles: manager, compute, and storage. Manager is master, which gives where all of the essential services like RCM, file server, and event server will run. Compute, compute role will give the memory and CPU to your applications. Storage role will give the storage disks to your applications. So you need to allocate roles to your systems. So what I'm going to do is I'm just quickly going to do Robin. I think it's host. Difficult to remember all commands, but I think add role. Now servers, Thinknyx master, Thinknyx worker, and I wanted to give, if you come here, I wanted to give all the things. I wanted to give them compute role. I wanted to give them storage role, hyphen hyphen wait. See here, processed, waiting. And as soon as this will happen, you will see this thing will go. This particular 2 nodes initialized, this thing will go. Come here, still waiting. See here, completed. If I do Robin host list now, do enter, see this. CS, C means compute, S means storage. Come up, it was not showing anything earlier. See here. So I have allocated compute and storage role to both servers. Now I'm going to primarily deploy everything on worker, but this is just to demonstrate how thing works. Right? Again, let me clear a screen. Come back. If I refresh this particular screen, you will see that above error will go. And see here, you are going to see something called hybrid nodes now. See this compute only node, only storage node, or hybrid. Hybrid means compute and storage. My both nodes are compute and storage. Now see here, this environment is not having any file collections. Now what is file collection? A file collection is like a NFS server, right? And this should be allocated to a server which is having manage role. We are running out of time, but I'm going to take 10 more minutes, everyone, so that you actually see the entire journey of this. So what I'm going to do is I'm going to actually allocate a file collection now, because once file collection is there, we people will be able to deploy our applications, and we people even will be able to start these metric servers also. It's all process. If you miss any step, things will not work. So let us follow the process. Now, if I do Robin collection list, you will see there is nothing. Right? Now, what I'm going to do is I'm going to actually create a thing. Now this is where your disks will come into a picture. If I do Robin disk list, you people will be able to see 2 disks are recognized. One more thing, which is worth to note, Robin host list, enter, see this. Earlier, nothing like this was coming. It was showing just hyphen, hyphen, hyphen. Now, as soon as you give a storage role, automatically your SymCloud platform will recognize there are two disks allocated to both individual master and worker servers, which I can utilize for PV and PVCs. Right? Next. Now, what I'm going to do is I'm going to create a collection. So, Robin collection list. It is showing empty. Now, what I'm going to do is Robin collection. I think it is create hyphen hyphen help. So, Robin collection create. So, Robin collection create collection type. So, there are two type of collections. One is file collection, one is log collection. So I'm going to create a file collection because I'm going to use it for my to storing my bundles and images. So I'm going to give this is equal to file collection, which is a by default value as well. Now next is if you see here media type. So I am having SSD. See this. So I'm going to give media type as SSD. And then I'm going to give the resource pool. Resource pool is default. And then I'm going to give replicas. By default, it will take 3 replicas, but I'm having one server, so I cannot give 3 replicas. So I'll give one replica here. Otherwise, it will throw me an error that you are having less servers because replication means different servers. It means I need to force it and I have to wait for it. Something wrong. It is hyphen hyphen wait. Enter. Hopefully this should work. Perfect. Robin collection list. Superb. So if you see here, 50 GB, whatever was available. One is again metadata. For metadata, it keep 1 GB. And if you see here, everything is here now. Replication factor 1, blah, blah, blah. Now, if you go back, refresh your dashboard, this error will also go, or this warning or suggestion will also go. See this. Now it is saying the environment does not have any bundles or application. Do you want to install any application? See here, step by step, it is showing everything to us. But I don't want to do bundling. First of all, I'm going to show you this metrics. Now, quickly, Robin metrics, METRIC status. If you see here, there is nothing. Stopped, stopped, stopped. Even in UI, if you go back, if you go under settings, and if you go under metrics, you will see the same thing here. So this output is actually, see this, it is stopped, stopped, stopped. You can start it from here. But I'm going to do it again using a CLI. So Robin metrics start hyphen hyphen help. Again, this thing I'm going to use resource pool as default, right? So media will going to be SSD. And if you see here, it is having, even I can give a Grafana port number also, if in case I want. Otherwise, it will by default take something. So let me give, let's say 32555. Again, from 30,000 to 32,767, I can give any port. And if you want Prometheus, let's say I give 32554, right? Again, I'm having a single server, so I'll give replicas equal to 1. And if I'm giving replicas equal to 1, I have to force it and I have to, fingers crossed, agent wait. Now, if you see here, it takes some time because it deploy agents, which is called exporters. I can show you, even you can do kubectl get pods hyphen capital A and it will show all those things. Let me open a new tab and show it to you. New tab. Let me log into a master. Master IP is 54.173.214.27. Still doing. It takes some time because it install agents, create multiple things, create PV, lot of things. Very good. See here, we are lucky enough it got completed, so I need not to open a new session to show these things to you. But anyway, see this. Now what it does, it actually, if I do Robin metrics status, you are going to see everything. See this. Prometheus is here, my dear friend, and Grafana is here. So if I take this, come back to now, even if I refresh this also, you will see the same thing here. One thing is missing in the UI, there should be a refresh button. See here, running, running, everything is all done. So if you come here, see this, you can click, open it. If I come here, enter, by default, the username and password for Grafana will be admin, and it will prompt you to change the password. I'll do it quickly. So admin, sign in, new password. Let me give one password, save, and here you go. Come, come to manage. See this dashboards. Example, if you go to Robin Prometheus, these are by default dashboards. So if I bring it to 5 minutes, you are going to see all beautiful things here. See this. Even it's not hard and fast, you cannot do things. Again, if you are familiar with Grafana, you can do a sourcing or you can create your own custom dashboards also, like I'm doing. If you come here, click, go to dashboard, you will see Prometheus 2.0, import this, go back to again dashboard, manage, you will be able to see something called Prometheus 2.0. Click here and it will actually going to show you other things as well. Less 5 minutes, see here. Even if you go back, come to manage, come here, see this cluster health and cluster summary. Click and it will going to show you some really nice dashboard figures. See this. See here, everything is 100% up, 100% up. See here. As time progress, you will see, more and more good dashboards. See here how simple it is. I need not to do anything. SymCloud platform is taking care of all these things for me. Go back. Let me show you a Prometheus also quickly. See here, these all are the ports 32555, 32554, which I have taken. Come here, quickly jump in, click, enter. As you know, Prometheus won't need anything unless and until you configure it. See this. I wanted to check the things. Come here. Let's say I wanted to see something up. So this is the query. Now this is called PromQL, Prometheus query language. Come, execute. See this. All time series values are here. Even you can click on Grafana, sorry, graph, and you will be able to see things here. See this. If you come here, come to status, come to configurations, or even rather better, you can go to targets. This is what it is actually scrapping. Kube API server, CA, advisor, nodes, pods, see here, service endpoints, node exporters, Prometheus, Sherlock, everything is there. So this is how all metrics enablement uh, can take care. So I'll come back here to the slides. So see here, file collection, metrics, and likewise you are having IP pool management. There are two type of uh, Calico pools which by default Robin creates. One is called Robin default, one is called non-Robin default. For Robin bundles, it will take the range from Robin defaults, and for other workload, it will take the things from non-Robin. So PDBs I defined, already explained you. RBAC, again, couple of things are there. Robin manage namespaces, and then finally your application deployments. So when you talk about Robin manage spaces, I'll quickly show you one thing. If I do kubectl get namespaces, you are going to see multiple things. See here. Now out of them, if you see here, these are something which is created by, if you see here, these are the one which are created by Robin. If I do Robin name space list, sorry, namespace list, you will be able to see. I think hyphen hyphen all should work here as well and show you all. See this. Now, these three are the one which are internally used by Robin SymCloud platform ecosystem. So these are internal one, and hence that's the reason they were not visible in Robin namespace list command. So these are little different than that of your, uh, you know, Kubernetes namespaces, right? So hopefully, in some other day, I'll specifically talk about Robin bundles and other things. But for the time being, what I wanted to do is I wanted to show you a quick application deployment now because we are running out of time, right? So if you go to github.com/Yogesh, what I have done is I have created something called, or rather, I should say, we have created something called SymCloud Platform in Action. Whatever have been demonstrated, all the things are there. If you see here, I have created multiple examples for deploying application on SymCloud. So you can use native Kubernetes approach, you can use Helm charts, you can use simple Robin bundle, you can have Robin bundle with pod and services, and even I tried my level best and finally created a voting app which is very popular in the examples, and I have created a Robin bundle out of it. So what I'm going to do is I'm going to deploy this particular application in front of you live now. And in case if any one of you is interested in checking the things, this is a public repo and anyone can go and take it. So I'm just going to clone this. I need to install Git. Yes, here Git clone done. See here, SymCloud platform in action. ls cd. Now all of the examples are here. I'll just show you, right? All the examples. See this. Even I'll just show you on the UI so that it will be easier for you. If I come here, now there are a couple of more terminologies which probably when we talk about uh, sometime next when we talk about storage, I'll explain all these things to you as well, right? So this is the demo I'm going to present now. So if you come back here, if you go to the SymCloud platform demo app, there are multiple folders. Example, you want to see Helm approach. So click here. All the application details and Helm chart details are here. And there is a README file. And inside this README file, all of the commands are given for you to just run and use. See this. Create, lint, check, history, blah, blah, blah. Likewise, if you come here, I'm going to use this voting app. If you click here, I have created a Robin bundle. This Robin bundle, again, it's a process. This is a link for understanding Robin bundles. If you go to docs.robin.io, bundle underscore guide slash latest, this will actually going to give you the details, how you can get started, right? This is like a Helm chart. Like you have to learn Helm chart. Likewise, you have to learn how to create or configure Robin bundles. So it's a Robin framework for deploying applications, right? So I have referred this entirely and have created this Robin bundle for you. If you come to this um, README file, all of the steps are given here. See this. So you create things, you put this, that, right? So if you come here, right, step number 1, 2, 3, 4, and you check the things will work. What I'll do is I'll actually going to do it live here. So voting app. Now my fingers are crossed. I hope this should work. If I do manifest.yaml, this is how we create Robin bundles. It's a specific, it's not Kubernetes YAML file. It's a Robin bundle YAML file, which is called manifest.yaml. And there are rest of the things like icons, script. Now, if I come back to the Robin application, if I come to the bundle, now what I'm doing is I'm creating a bundle. Now, if you come to this bundle section, it will going to be empty at present point in time. I'm creating a bundle and I'm going to upload that bundle here. It means I'm creating my marketplace. Then you give the access to any developer or anyone in your operations team. They will log in, they will come, they will click a button, application got deployed, all done. Right? So as a developer, I'm developing this bundle and I am putting it here. right? See here at present point in time, there is nothing. Even you can put icons to it. So I'm going to put a Thinknyx icon as well. So if you see here, there will be a directory called icon. And if I do cat icon or do ls icon and do enter, see this Thinknyx dot. So this image will be there, right? So next, what I'm going to do is I'm actually going to create a tar file now. So see here, these all are the things, coding and everything, bundle creation is done. I'm going to convert that bundle into a tar file, which is actually going to be my Robin bundle. So tar hyphen cvzf, and I'm going to say, let's say voting app dot tar dot gz, right? I'm going to give a star to it because I want everything to be there. ls, see this. This is my Robin bundle now. Now it's a Robin bundle, but it's in my server. I need to upload it. So what I'm going to do is Robin bundle add. I'm going to give it a name. Let's say voting app, right? And let's say I'm going to give it a version 1.0.0. And then I'm going to give this. You need not to remember it. Just do voting bundle add hyphen hyphen help, and you will see it will tell you to give a name and a version, which I am giving. Do enter. Better I should have given hyphen hyphen wait. If you haven't given hyphen hyphen wait, you need to specifically run a job with job ID to see what is going on. See here, it is completed. My bundle is there now. Go back. See this. Oh, wow. So finally, I'm having my own Robin bundle uploaded on my SymCloud platform. Now, as a normal user who is having access to deploy application, what I have to do? Click. As soon as you click it, it will actually going to create a template. Right? So everything is connected internally. It will going to create a template. See this name. Let's say I'm giving Thinknyx app. Now see this thing. You will not see these things in normal Kubernetes. Static IP, secondary IP. Now, when you talk about secondary IPs, it means we are talking about multiple interfaces as well. Right? So multus like CNIs will come into a picture. Static IPs, pod is gone. Same IP is given to another pod, which is recovered or self-healed. See here, CPU core, we are giving one. So if you come here, I'm giving 256 MB of, I'm not giving any storage, right? Done, done, done. Now, if you see here, vote and result. These two are the things which I have actually mentioned here in my manifest file. See this. This is called role. This is vote role and this is result role. So vote and result role is here. Vote, which I have filled. Now this is result. Shared one core CPU. I will give 256 of MB of this. And finally, I need to say provision application. Hola, all done. You will see it. See here. It will deploy voting app. It will deploy result app, and backend it will deploy your Redis server, your worker, .NET framework, pod, and your DB as well. See here, all done. Close, come back to the application. Just click to this application and you are going to see everything here. See this, my application. Wow. Bundle, who is owner, under which tenant it is, on which server it is running, right? What is the container status? You are going to see everything here. Come back. Let me come to a bundle. Click on this application and you are going to see the entire details about this application. See this info. Let it come. See here. This is the information about vote. This is the information about result. You can do multiple things from here. See this. You can take the console, click here. It will going to take you. It is like kubectl exec. It will going to take you inside a pod or inside a container which is running inside a pod. See this. Like likewise, you are going to have many other features. You can scale up, scale down, stop it, restart it. Come here, see this. You can add volumes, blah, 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 all those things. Let us go to this network, see here services. One is running on 30021, one is running on 30020, right? So let me take this 30020 and 34229. So 34.229 and 20. See here. And if I come here, 21, see this. If I come, I give me a thumbs up. See here, it got registered. Then it is going to .NET Framework, getting registered to DB, and DB is reading it. Now, as it is coming up, so it takes some time to reflect it over here initially. So let's wait. You will see things will come here. So this is how what you can do is you can deploy your applications. So till the time it is actually see here, it started working now. Come. If I scroll it down, one vote down. If I scroll it up, one vote up. Now, what I want you people to do is now it is not easy for me to speak for a long now, but what I want you people to do is I want you people to rate this session. I just wanted to see where I stand. So you just go to your browser, http colon slash slash 34.229.129.199 colon 30020, and it will actually going to give you this browser. And I just want you people to give me a vote and let us see where I stand. Again, this is the IP 34.229.129.199, and the port to give a vote is 30020. Right. So I'll quiet for 1 minute and see what happens. So it is HTTP. It should not be HTTPS. HTTP colon slash slash 34.229.129.199. And now I'll just bring things here and see what happens. See here, there are 2 votes so far. 3 votes so far, 4 votes so far. So if you see here, you will see as soon as you people will register a vote, the things will automatically going to come over here, right? So you will see things from up, things from down, things from here, and you will see the things will go. Quickly, just 1 more minute. Ten votes, 10 seconds more, or 20 seconds more. Perfect. So 11 votes. If you see here, the purpose is just to show you that it works. So if you do down, it will actually going to get registered. If you do up, it will actually going to get registered. Right. So with this, I am done. I am really sorry I took more time, but I don't want you people to miss the important things, and hence the session got dragged for 30 minutes or so. But thank you so much, everyone.